Hello everyone, you're welcome to today's episode of Mathematics Tutorials brought to you by MATHcare Mathematics Tutorials. My name is Eric. Now, here is our daily math problem. Now, this is on geometry and the subtopic is similar triangles. All right. Now, what are similar triangles? In this tutorial, our aim is to identify similar triangles and understand the properties of similar triangles and be able to apply them in solving problems. Now, this question says that if triangles ABC and DEF, that is ABC and DEF, are similar, find the lengths of the third sides of both triangles. All right. So what it means is that the question has already told us that these two triangles are similar. But let's find out why or how two triangles are similar. How do you know if two triangles are similar? So we'll look at the properties of similar triangles. So properties of similar triangles. So we write here in short form, that is properties of similar triangles. So let's put here the first one is similar triangles are what? They may have the same shape. So let's say same shape. So they may have the same shape, but so we have a but not necessarily not necessarily the same size. So similar triangles may have the same shape or they have the same shape, but they do not necessarily have the same size. So triangle ABC and triangle DEF are similar, but then we can see that their shapes are not, the shapes are the same, but their sizes are not the same. Their sizes are not the same because we could tell from what the lengths that are given that they are not the same. So that is one property. The second property is that the corresponding angles are congruent. That is equal. They are congruent. So corresponding angles are congruent. All right. So that is, if corresponding angles are congruent, it means that angle A, the angle at A, will be equal to the angle at D, or the angle at B will be equal to the angle at E. That way, we say that the angles are what? Congruent. But then these triangles, we are not defining them to be similar in terms of the angles or in terms of angles. We are defining them to be similar in terms of their sides or their lengths, because we are giving their lengths and not their angles. All right. Now, let's look at the third property. The third property about similar triangles is that there are corresponding sides are in the same proportion. All right. So their corresponding sides or lengths are in the same proportion. It means that if we are saying that triangle ABC is similar to triangle DEF, then it means that their corresponding sides. What are their corresponding sides? What are the corresponding sides of these two triangles? AB is the side AB is corresponding to the side DE. The side BC corresponds or is corresponding to the side EF. The side AC is corresponding to the side DF. So that is what we mean by corresponding sides. all right, or corresponding lengths. All right, so in this case, what we're going to do is that knowing all this, we can see that these triangles are similar, not because now because we can say that they have the same shape. Then for angles, we cannot talk about the angles because we are not given angles. But what about the corresponding sides? We can use the corresponding sides because we can relate these two triangles and say that they are similar in terms of the fact that their sides are in the same proportion, because we have already been told that these two triangles are similar. All right, so if they are similar and so the corresponding sides are in the same proportion, then it means that the corresponding side, that is AB, is equal to EF, that is the corresponding side, and then BC, that is AB, is corresponding to the side DE, and then BC is corresponding to the side EF, and then AC is corresponding to the side DF. That is what it means. So we can write out this, and then we'll be able to find the length of the other two sides. Now, to be able to find the length of the other two sides, what we need to do is that we shall write, we shall put the corresponding sides of these two triangles in proportion, in the same proportion, and then we'll be able to solve for the value of x. Knowing this side AD, we need to know the value of x. So knowing the value of x and multiplying 2 by the value of x and add 1, we shall know the side AC. Same way, if we have known or we have already solved, or when we solve for the value of x and multiply the value of x by 2 and add 5, we shall have the side DF. All right, so let's come here to look at the solution. So let's put this over here, and then so this is also part of the solution. So let's put here solution. So now in solving, what we're going to do is that we are saying that the corresponding sides are in the same proportion. So the corresponding sides, that is AB, we can say that from the diagram, we can say that AB, the side AB, is proportional to, or it's in the same proportion to the side that is DE. So that is DE, and that is because it's proportional. So that will be equal to the side BC is proportional to the side EF. So BC is proportional to EF. So the side BC, so BC is proportional to EF. So we have EF, and that will also be proportional to the side AC is proportional to the side DF. So we have the side AC, so we shall have AC to be proportional to the side DF. So we shall have here DF. So this is what we have. So now, what is the side AB? AB is 4, so we shall have here 4 out of 6. ED is 6, so what is DE? DE is 6, so we shall have 4 out of 6, so we shall have 4 out of 6. This is equal to, what is the side? Oh, I wrote BC, sorry. So this is BC, so BC, and then that is EF. Sorry, so EF, so that is EF. So this is EF. That is EF. It's proportional to EF. So what is our BC? BC is 6, so we shall have 6 all over what is our EF? Our EF is 9, so that is 9, and that is proportional to, what is our AC? AC is 2x, so we shall have 2x plus 1, so 2x plus 1. This is proportional to df, and df is 2x plus 5, so we shall have 2x plus 5. So this is what we have. Now, in continuing, we will have to wipe this side so that we will continue from there. So let's wipe this side to make space for us to continue with the solution. So let's so from here, what you're going to do is this. As you're watching the solution, do share the work, please. Share this video, and then also don't forget to subscribe to our YouTube channel so that you'll be notified whenever a new video is uploaded. Don't forget to follow me on Facebook also, and on Twitter, and then on TikTok and Instagram. So now let's continue from here. So what we have is that we have 4 out of 6 is the same or is equal to 6 out of 9, which is equal to 2x plus 1 all over 2x plus 5. So if that is the case, then it means that 4 out of 6 is in proportion or is proportional to 6 out of 9. So let's put here 4 out of 6 is proportional to 6 out of 9. And so these we have said is proportional to 2x plus 1 all over, or that is proportional to 2x plus 5. So this is what we have. So if 4 out of 6 is proportional to this, which is proportional to this, then it means this is the same as this. So we could equate 4 out of 6 to be equal to 2x plus 1 all over 2x plus 5. Or we could equate 6 out of 9 to 2x plus 1 all over 2x plus 5, because we are saying that this is equal to this. So this is the same as this. So we could use any of them and we shall arrive at the same answers for x. All right, so what you're going to do is that, so this is what we do. You can decide to use the smaller number, which is 4 out of 6. That is the side 4 out of 6. So let's use 4 out of 6. So 4 out of 6 is proportional to 2x plus 1 and 2x plus 5. This is what we have. So let's write this properly. So now what you're going to do is we can cross multiply. So we shall have 6 multiplying 2x plus 1 to be equal to 4 multiplying 2x plus 5. And so we shall expand the brackets. So 6 times 2x will give us 12x. So we shall have 12x plus 6 times 1 is 6. This is equal to 4 times 2x is 8x. And then plus 4 times 5 is 20. So let's group like terms. So we shall have 12x to be equal to 12. That is 12x minus 8x is equal to, now it's minus 8x because when 8 crosses the equal sign becomes negative x, negative 8x. So this becomes 20. Then 6 will cross the equal sign to be minus 6. So we shall have 12x. That is 12x minus 8x will give us, this is going to give us 6. And so that is it. So 12x. This is 4x. This is equal to 20 minus 6, and that gives us 7 times 2, that is 14. So that gives us 14. So we shall have 4x to be equal to 14. All right. Now let's put now let's make use of this space over here. So we have 4x is equal to 14. So if we have 4x is equal to 14, then it means our x is equal to 14 out of 4. And so our x is equal to 2 into 14 is 7, and 2 into 4 is 2. So we shall have x to be equal to 7 out of 2. All right. So now if x is equal to 7 out of 2, then how are we going to find the values of the third side? That is AC and DF. Those are the sides that we are to find. All right. So now let's come here to conclude. So what you're going to do here is that let's roll a line over here and make use of this space. So AD, side AD, so AD will be equal to, if we are to find the length of AD, we shall find the length of AD now knowing that x is equal to 7 out of 2. So we shall substitute the value of 7 out of 2 into the side AD. So AD is equal to 2x plus 1, which is equal to 2 multiplying x is now 7 out of 2 plus 1. And that will give us 2 or cancel 2. We have 7. 7 plus 1 will give us 8. So we have 8. So that will give us 8 units. And then we have the side DF also. So we say DF is equal to 2x plus 5. Now, if dx is equal to 2x plus 5 and rx is equal to 7 out of 2, so we shall have 7 out of 2 plus 5. And this will be equal to 2 cancels 2. We have 7 plus 5, and that gives us 12 units. So we conclude by saying that the side AD in this case will give us 8 units, and the side DF will give us 12 units. Now remember that we used this side, which is the side AB over the side ED. In this case, 4 out of 6. We equated it to the sides AC and then to be proportional to AC and DF, and then we arrived at x being equal to 7 out of 2. Now, if you use, because we have said 4 out of 6 is equal to 6 out of 9, it's proportional to 6 out of 9. Even if you use 6 out of 9 and equate it to this, which is 2x plus 1, all over 2x plus 5, you're going to arrive at the same answer for x to be equal to 7 out of 2. You can try that and see. And then this brings us to the end of this lesson. Thank you very much for watching. We shall have another example in our next video where we shall have angles, and we'll be able to prove whether two triangles are similar or congruent. On that note, thank you very much for watching once again. See you in our next and other videos.